Thank you, Heng Chi. And I'd in particular like to thank Minister Balakrishnan for his very comprehensive comments. And in a sense, he's, I think, introduced the topic very well, and he's made my job much easier. I'd like to start to describe an early encounter I had with big data, and this was in 2002. I met Admiral John Poindexter, who is famous or infamous, depending on your point of view, but he's an excellent engineer. And he was then heading DARPA's Total Information Awareness Office. And in a 45-minute tour de force, with just two of us sitting down in his office, he sketched out the system architecture for scanning a massive number of databases to search for the proverbial needle in the haystack. And in this case, the needle would be the terrorist trying to hide in the shadows. Now, Poindexter convinced me that the technology to do this at that time was available. And the establishment in Singapore of the Risk Assessment and Horizon Scanning Program, or RAS, followed. Now, RAS is a computer-based suite of tools that searches databases for weak signals that could evolve into sudden shocks. If used intelligently, it can enhance the quality of planning and decision-making. Now, there were two small ironies associated with RAS. First, Poindexter had to resign from DARPA over some unrelated controversy. And as a result, the TIA office closed, and the good work which he was doing went black, undoubtedly resurfacing several years later in some form or other, not unconnected to the revelations of Edward Snowden. And this probably made RAS, our RAS, the first open variation or variant of Poindexter's ideas. The second irony was that although RAS was developed for national security purposes, it actually found greater application outside this field. Our Ministry of Education has used RAS to evaluate changes to certain teaching syllabi. Our universities have used RAS for teaching, covering arcane topics such as how agricultural products are priced and how to model the risk environment for commodity trading. RAS is now deployed in applications not envisaged when the program was launched in 2004. A major area is in sense-making, using methods like narrative capture, semantic analysis to better understand the attitudes and moods of the people. And such methods can often produce more useful and accurate outputs than conventional survey techniques. And through sense-making, we can acquire a better understanding of human social networks, what they are thinking, what they're doing, how they're performing. And this significantly aids policy making and has huge potential in business. I recount the story of RAS in order to make two important points. First, RAS was among the first computer-based systems to exploit big data before the term gained any kind of currency. So big data is not new, certainly not in Singapore. It is like the smart nation in Singapore to the intelligent island of many years ago. This is also Singapore, the intelligent island. What has changed is the technology and the processing algorithms to exploit it. And this has significantly improved in the last several years. Second, the potential benefits of big data are not necessarily obvious. Instead, many benefits are only discovered through a process of experimentation, trial and error. And this is because many of the benefits are often derived from connections that are often hidden or not obvious. So that is why RAS has set up an experimentation center, or RAS Experimentation Center, in order to try out new ideas and to discover new applications. Now, why is big data important? We talk a lot about it, but we have to ask ourselves why it is important. Both Minister Balakrishnan and Tom McEntee have spoken about how big data is rapidly increasing. It's exponential, and the pace has been remarkable. 1999, the world produced a total of 1.5 exabytes of unique information. And 1 exabyte is equivalent to about 1 billion gigabytes. But in 2012 alone, the world produced 2.8 zettabytes of new data. I think Tom mentioned this amount. By 2013, it was estimated that 90% of all data in the world had been generated in the previous 2 years. And the reason for this exponential growth is attributed to the proliferation of computers, mobile devices, growing number of sensors. Singapore is a prime example. The smartphone penetration is almost 90%, and it eclipses the levels of most developed countries. Now, we're also talking about the proliferation of sensors. The Internet of Things, cloud computing, now captures an increasingly massive amount of data. The unprecedented scale of human communication and content generation through the use of social media, such as Twitter, Facebook, Instagram, YouTube, blogs, online chat groups, you name it, that's all part of the way data is growing on such a large scale. Secondly, huge strides have been made in the technology to process big data. Today, up to 80% of data is unstructured, including images, videos, voice recordings. But new technologies and advancements in analytics now enable us to turn such unstructured data into useful content, and I think Steve Koonin gave a few examples of how this is being done. The greater variety of multiple data sets can now be combined, analyzed, and cross-referenced for new insights. It is like we have discovered a new big search button for big data. Press search and somehow something comes out at the end. Even greater value can be obtained because such data can now be processed and analyzed in real time. For example, if data is captured in near real time, advancements in statistical techniques and algorithms enable it to be analyzed in real time to produce useful output. For example, bus arrivals, delays, so on, can be immediately registered. And then apps can be developed to push out alternative routes to commuters with feedback to the system to allow it to intelligently forecast and help redirect crowds and prevent bottlenecks. This is an aspiration for Singapore. We hope we will have it. And it seems that the only constraint on exploitation of big data is the limit of our imagination and our ability to see patterns and to make connections. The optical microscope was invented in the 17th century. It enables scientists of the day to view things that were already present but not visible to the human eye. It revolutionized science and medicine. Big data is in a way analogous. With the right tools based on computing power, the internet, mobile telecoms, real-time geospatial information, we can now observe relationships that could not be readily analyzed in the past. The insights derived can significantly improve governance and policy making on the one hand, and make the lives of ordinary people more productive and convenient on the other. But it would be a big pity if the benefits of big data are framed within some kind of Big Bang impact. A lot of time would then be squandered trying to put together the next big thing, when instead there are many more low-hanging fruits to be plucked. To me, the benefits of big data should be associated with aggregated benefits of many small wins. That is not to say that killer apps will not emerge along the way, but it is much more important, in my view, to create the environment to facilitate the exploitation of big data. And with sophisticated technology accessible to everyone, the applications that do not need any kind of massive investment in R&D, instead they depend on the willingness to share data, on ideas, on insights and inspiration to create and deliver something of value. A recent initiative of Make Health Connect, a network of 1,200 clinics, is Singapore's first disease map. It delivers real-time information online, focusing on infectious diseases that patients are seeing doctors for. Now, the disease map shows where the viral and bacterial infections have occurred, from dengue fever to chicken pox to upper respiratory diseases. It is unlike the semantic approach of Google Flu Trends. You know, Google Flu Trends looks like how many times people have searched for flu or symptoms of flu. Instead, it is based on the actual diagnosis submitted online by doctors in the network, and it is refreshed hourly. The argument for such systems is that the traditional method of surveillance to predict disease outbreaks involves the labor-intensive and time-consuming collection of static data from hospitals, clinics, and laboratories. And you have to read the doctor's handwriting as well. Cities will be among the most important users of big data. Just a couple of years ago, the percentage of the world's population living in cities crossed the 50% mark. But the number of urban residents continues to grow steadily, in fact by almost 60 million every year. By 2050, more than 60% of the world population will be living in cities. In Singapore, and it is one of the most densely populated cities in the world, we are witnessing big changes in society and the environment. These include an aging population. 1 in 5 citizens will be 65 or older by 2030. And yet also a growing one, as we have to continue to attract and integrate talent from overseas into the Singapore population. Clearly, the urban milieu poses huge challenges for planners and decision makers, and these include sustaining economic growth, achieving environmental sustainability, and fostering social resilience. These urban challenges are escalating in scope and complexity. Firstly, it is important to appreciate that cities are complex systems. Connections and interactions within a complex system, such as a city, are extremely difficult to detect, inexplicable without hindsight, and are emergent. Secondly, the agents within a complex system like a city, and these are the people mostly, are countless. Each person generates a lot of data, much of which is location-based, as Steve Koonin explained. And combined, all this constitutes big data. Special tools are needed to deal with this urban complexity. And this is where big data is of particular significance. Complexity science offers a way to marry different tools, such as agent-based modeling that is used inter alia for things like traffic flow dynamics, and combine with insights from big data to provide a better understanding of the city. So if we can take a big data view of the city and see the city differently through new lenses, what are the fresh possibilities to imagine and shape a different and possibly better city for the future? ePlanner is a geospatial planning data analytics portal developed in-house by the Urban Redevelopment Authority, or URA. ePlanner is a powerful tool that helps urban planners in strategic and daily planning and decision making. It integrates big data from various sources, enterprise systems, various government agencies who have volunteered to share their data, open data, and the public domain to perform geospatial data fusion analytics. Through data visualization, ePlanner makes complex GIS and data analytics more intuitive and user-friendly for all planners. ePlanner is populated by a rich array of data sets, including land use and development constraint data, development and planning decisions, what decisions have been taken in the past, population and demographics, as well as mobility and ground sensing information. As a result, it actually mirrors the complexity of the urban setting. But it also has the forensic tools to provide insights into various aspects of the city, either at an operational level or at a holistic and strategic level. And some applications of ePlanning include identify more precisely the optimal locations to build social facilities based on residents' needs and their demographic profile. And I think Minister Balakrishna's presentation showed how some of these applications might work for the elderly. Analyzing the use of new developments on traffic and demand and usage of surrounding amenities. And analyzing sentiments and ground feedback and other planning constraints to assess and plan for new sites for development. URA is now enhancing ePlanner to include big data analytics such as anonymized real-time travel, traffic, and parking using data from sources like EasyLink. EasyLink is a payment card used by people in the mass transit system, parking, real-time telco data in order to better understand pedestrian and vehicular movements in the cities. Because it is a common platform, ePlanner enables many government agencies to share up-to-date information and to make collective planning decisions with a strong alignment of efforts. For governments and municipal authorities, the large volume of multiple data sets provides an opportunity to leverage on big data analytics and the use of recombinant data to generate new insights. And this in turn increases the scope to improve public service delivery and to improve resilience through better predictive management. One example from New York, if I may, is the identification of illegal house subletting. A case study showed how the correlation of data, if you can get them to cooperate, 19 different agencies in the New York City setting, including anomalies in utility consumption, missed bill payments, rodents, and noise complaints, could increase the accuracy of identifying illegal housing subletting incidences for building inspections. Key is to get the agencies to share their data. So this data storage store is a good way of getting this done. The vision of a different city is only limited by our imagination. Businesses have shown how they can create new concepts and disruptive ideas with current technologies just by identifying gaps and fulfilling people's needs. Uber spotted commuters' desire for responsive taxi service, so it deployed data analytics to allow commuters to get a taxi, private car, or ride share to their destinations. Uber was the first mover, and everything else since then has just followed in its wake. Airbnb, which is Uber's analog in the housing, apartment, rental market, caters to short-term stays, such as tourists, and it underlies how spare capacity can be optimized as a scarce resource. Big data initiatives like Uber and Airbnb are creating a new type of economy, the shared economy, and these are just early days, so we are just watching the start. As urban issues become increasingly complex and cross-cutting with greater interdependencies, multiple sources of data will be needed for effective analysis, and this points to the need for greater openness of data. To unlock the true potential of data in the complex environment, we need to be open and creative in the use and sharing of data. If we restrict access to this asset to planners and policymakers, we will miss out on the opportunity for communities to interact and search for solutions, either from the top down or from the bottom up. Data has to be a shared resource to which the biggest benefits are likely to emerge from fresh data intersections, patterns, and connections that we do not yet know about. The ability to do micro-planning, as shown for the elderly, depends on data sets being open for sharing. To realize this vision, we will need to adopt a dare to share mindset, first across government agencies, and then opening up more data for public access. An example is the DataBridge store. It requires a huge change of mindset and must change the embedded theology of need to know. It has to be, it's more than just being machine readable. Agencies have to think data is something that we benefit more by making it open rather than keeping it classified and confidential. In 2009, on his first day in office, President Obama signed a memorandum on transparency and open government, committing the US government to take active steps to unlock government-held data. A similar initiative in the United Kingdom launched the Open Data Institute, led by Tim Berners-Lee and Nigel Shadbolt, and it is based on the premise that all data generated by the government is public infrastructure until proven otherwise. And I fully endorse this philosophy, and I hope that Singapore will embrace it as well. Now, Chan-In-Chi said that big data can also be a troubling manifestation of Big Brother, and I don't think we can brush this concern aside. The Pew Research Center Internet Project 2014 survey on public perceptions of privacy and security in the post-Snowden era found that adults expressed varying levels of sensitivities pertaining to different types of data. A good starting point is to distinguish between data which is of personal value and should be protected at all costs, such as personal identification. In Singapore, it would be the national identity card, and that which may have social value that could be maximized for the greater good if handled with care, such as daily travel patterns, cell phone location data. In the process of finding an appropriate balance between managing data privacy, confidentiality, and preserving personal choice on the one hand, and increasing the public good on the other, a sober conversation needs to be started among governments, private entities, and the people who will continue to be the ultimate users and generators of data, but articulating both the benefits as well as the risks involved with different types of data sensitivities. But data is only a step along the journey. What are we trying to do? An early example of an app that can push info on the bus arrival times in the event of a delay is one which can help improve the convenience in our daily lives while encouraging more sustainable life choices, such as taking public transportation. And we can also imagine driverless taxis that allow shared trips to reduce pressure on roads while meeting passenger demands. We could also imagine traffic lights that change in response to traffic conditions that are monitored by sensors on the roads. In our smart homes of the future, we can look forward to informing occupants of their energy usage and usage patterns through sensors and smart devices so that they can monitor and modify their usage to save costs. Big data can also help to strengthen communities by connecting people of the same neighborhood or of common interests and hobbies. In societies that are rapidly aging like Singapore, this could mean placing a network of sensors in the homes of the elderly, which could monitor and track their daily living patterns and movements, and to send out alerts to family members and neighbors when they deviate from daily norms, such as the frequency of use of toilets, fall detections, and so on. In other words, when we think about infrastructure, let's also think about infrastructure for big data. From the point of view of urban governance, big data could also allow agencies to track and monitor the development and staging plans of key infrastructure in tandem with population and economic growth. It could also be used to support strategic long-range scenario planning in land use, transport, and infrastructure. In the development of new housing towns, big data can be mined to better understand the demographic profiles, needs, and social aspirations, so as to better provide amenities, facilities, and options for the residents. Now, Chan Hee-Chee mentioned big data being characterized by volume, velocity, and variety. Actually, there's a fourth and a fifth. The fourth is value. Big data is not there just for its own sake, it's there to generate value. But the fifth is also vital. You must have vision. The vision to see where and how big data can be applied purposefully to improve livability in the context of cities. To conclude, big data can give us the unprecedented opportunity and power to analyze and see the city differently, in the hope that we might see a different city of the future. And if we can imagine a different city of the future, we can then take active steps towards realizing it. Thank you.